Hello, this is Dr. Kalman Andrassy, and I'm going to be discussing various types of tests as well as basic research study designs. So, where we kind of need to begin with this is to think about what it is when you actually make a measurement with an instrument, right? You're taking some sort of a score, right? And that score is then compared to other scores or to some sort of a standard, and you come up with a conclusion about the status of whatever it is that you're measuring based on those references, right? So the place where we're going to start here in discussing the observations that we make, in other words, the tests that we perform, the actual measurements that we're able to make. Let's discuss the difference between a norm reference test and a criterion reference test. Okay, so a norm reference test is when the tests are done and basically a single score is compared to the performance of the entire group. Okay, so for example, if you recall any of the tests that you may have taken in the course of your high school career, whether it be taking the SAT or taking one of the tests that are performed at the end of the school year, the standardized tests that take a look at how a school is performing in relation to other schools, chances are you've seen your percentile rank with regard to the other students. So if you rank in the top 64th percentile, it means that your score is as good or better than 64% of other students. If you're in the 95th percentile, your score is better than 95% of students. And of course, 99% would be better than all but 1% of the entire population of students that take a particular test. That's what a norm reference test is. It looks at what the average is of all the scores and essentially tries to rank you based on how well you did in relation to other students. Okay? The second type of reference test is the criterion reference test, and that is basically how an individual performs against a particular standard that is set. So basically the idea behind that is that if you want to pass a subject in order to get like a license or something like that, getting a real estate license or a medical license or any kind of license, you have to get a particular score on a licensure test. That's what a criterion referenced test ultimately is. It's what is that minimum score that you have to get, and go ahead and try to surpass that score in order to be able to pass. Okay, so basically what you're hoping to do is, if you're doing a norm reference test, you probably want to try to make that medium difficulty so that not everybody gets it right, but not everybody necessarily doesn't know what the answer is either. Whereas with a criterion reference test, it doesn't matter how hard or how easy the test is. You only have one level and you have to reach for that. If you don't do it, if it's too hard, it's too bad under a criterion referenced sort of score. So, if you go to the DMV and you're getting your driver's license, you have to take a test and get a certain number correct in order to obtain that license. That's the whole idea behind a criterion reference test. Okay? Now, moving on, we have two other groups of tests. There are tests of optimum performance and there are tests of typical performance. When you think of a test of optimum performance, you're thinking of tests like examinations and things like that, where you're trying to do ultimately your best in achieving whatever it is that you want to do as well as you can essentially on that test. either to beat the norm or to reach the particular criterion. Whereas a test of typical performance, your actual performance doesn't matter because it's usually in the form of some sort of a survey questionnaire. So let's start with tests of optimum performance here. We have three major groups: achievement tests, aptitude tests, and intelligence tests. And I'm sure you've heard of all these different types of tests in the past. An achievement test is like the test that you would get in a classroom. It's there to kind of test what knowledge and skills you may have acquired in the process of engaging in something. Usually it's going to be probably multiple choice, maybe with some open-ended evaluation assessment questions as well. It's going to basically tell you whether your score is above average in some way, average, or below average, or even poor in certain cases. So as with tests and exams that are given in class, you get an A, B, a C, a D, or an F grade on those particular tests, or a certain number of points. That's a type of an achievement test because you're ultimately seeing and rating what your performance is based on the number of answers that you get correct. Okay? An aptitude test, meanwhile, goes beyond just testing individual knowledge and skills that have been acquired, but rather they try to measure a very specific type of achievement in sort of a comprehensive fashion. And one of the big examples of this is the College Board's Scholastic Aptitude Test, the SAT, which many students take in order to improve their chances of getting into their college of choice. And the idea there, of course, is that you have math skills as well as English skills that are sort of test under that test, and in that case it's a particular criterion reference sort of test that is also based on the criterion are established based on the norm of the scores that are presented. So you do get a percentile score, and then of course based on the percentile that you meet, you get a particular number that can kind of be looked at as a criterion reference score. Or if you get a perfect score, it's going to be a certain number. I think it's 800 for a particular section, and then you get points assigned based on the actual norm that was acquired. And then of course different schools have different requirements for what the scores need to be in order for a student to be able to get in. Some schools may require a 700 on the English and a particular score on the math test in order to get into a particular major or program as a freshman. So that's the idea behind an aptitude test, is trying to ultimately predict a specific type of achievement. In this case, ability to be successful in college and get a high GPA in college. The problem is that they tend to have rather low to modest validity. I mean, of late we've seen these types of commercially available aptitude tests like the SATs and the ACTs often having validity coefficients. That's the correlation test that you're going to be learning in the future. You're probably going to see about a 0.2 to a 0.6 validity correlation coefficient score, which isn't necessarily all that great. Certain tests may be better predictors of college performance than others. But that's actually one of the main reasons that a lot of schools are dropping the SAT requirement. They aren't a perfect correlation between determining how somebody is going to perform in college, what their GPA is going to be in college based on that test. Okay. Last but not least, we have intelligence tests, IQ scores basically, that try to predict achievement in general. And there are lots and lots of different tests out there that try to determine how intelligent individuals are, how well they're likely to perform academically and otherwise. But much like some of these aptitude tests, you tend to have lower levels of validity in intelligence tests, due in large part to the fact that they do tend to be culturally loaded, and they measure knowledge and skills that usually can be acquired with instruction. So what you actually tend to see is that people with advanced education, people with bachelor's degrees, master's degrees, doctoral degrees, the more education you tend to have, the higher you tend to score on an intelligence test. So there are efforts to make culture-free intelligence tests that try to measure innate ability, but they aren't necessarily 100% great at measuring what a person's overall achievement is likely to be in any given field. Okay? And then we can kind of contrast this with tests of typical performance. Again, it's all about measuring perception or relative performance rather than any sort of specific there's no score you're trying to achieve. There's no norm that you're trying to beat. It's all about examining a person's personal feelings about things, their typical levels of performance rather than the higher level achievements or anything like that. Okay, so with that, the thing that you have to kind of pay attention to in a test of typical performance, which is probably what most people are going to be doing to collect data, to do survey research and quantitative research. They're trying to get attitudes, feelings, perceptions of things, rather than necessarily knowledge about particular subjects. So if you are, looking to get those kinds of bits of information, the thing you have to kind of pay attention to is whether or not the individuals are trying to provide socially desirable answers in giving their responses. A lot of people are hesitant to reveal that they have socially undesirable traits. Even if they don't necessarily have anything to gain by being deceitful. One of the reasons that people attribute the polls in the year 2016 going for presidential candidate Hillary Clinton rather than Donald Trump is that Donald Trump was seen as a very divisive individual that had some socially undesirable traits, and people were hesitant to reveal that they would be voting for Donald Trump because they didn't want to be associated with some of those negative traits that might be associated with him. So what you need to do as a researcher is you need to try to find ways of reducing the influence of social desirability, and in doing so increase the validity of your study. And some suggestions that I have here for that is first and foremost to try to make your test or your survey tool anonymous if possible, right? In order to reduce the tendency for people to give socially desirable responses. Anonymity allows people to not feel the pressure of giving a socially desirable goal because nobody's going to know that you had the socially undesirable characteristic to begin with. Okay. Another is to try to make it as unobtrusive or secret as possible. In other words, make sure that people are not made aware of the location or the measurement as much as possible, as much as ethically possible. So, one of these is to not necessarily reveal the location in which a particular survey is being administered, or something along those lines. Keeping it as secret as possible that somebody participated in a survey as possible. It kind of lends itself towards that goal of anonymity. And you're able to then go ahead and rate potentially negative characteristics in a different way. And of course, another way to kind of do that is to score characteristics that could be considered to be socially undesirable in interesting ways that I'll talk about in a little bit here. Projective techniques. I don't have that on the list there, but that's another thing that can kind of try to pull information out of an individual without necessarily being obtrusive. The idea there, like you have very loosely structured or even ambiguous kinds of stimuli from which you're able to garner whether or not somebody has, potentially negative characteristics and things like that. Like an ink blot test, the old Rorschach test that I'm sure you've all heard about at some point in your academic or personal lives. The problem, of course, is that the validity and the reliability of projective techniques can be very lackluster, and they're very seldom used in personality research because of that. Another very good suggestion is to use Likert scale questions to ask questions. So those are where you categorize responses as far as strongly agree, neutral, disagree, and strongly disagree, or some variation thereof, or you have different degrees of agreement without necessarily putting a number to it, and it goes beyond just the yes or no that you would get in sort of a dichotomous nominal category like that. So the idea there is that it's really good for attitude-like questions, where you're able to get a pretty good idea of how people feel about a particular topic, and it does allow for a bit less obtrusiveness in terms of the way in which the questions are kind of asked. Okay? Reverse scoring is yet another technique that you can potentially use, especially as far as obtrusiveness goes. So instead of asking about questions like aggressiveness or something like that, you kind of ask the opposite question. How calm are you in the classroom, instead of how aggressive are you in the classroom. So that if somebody scores lower, you can attribute that to more aggressiveness than if somebody scores a lot higher on that test. So then that way, it takes away some of that social desirability, confounding that could potentially be in there, and and lead to more accurate types of responses. So yeah, basically, if you score if you do use a Likert scale question, you say that you strongly agree that you believe in one thing, it means that you probably would strongly disagree with its opposite, and really get into some of those more socially undesirable traits without influencing too much how individuals will kind of defensively respond to those kinds of questions. Okay, which brings me then to the next topic of discussion, which are experimental, pre-experimental, and quasi-experimental research designs. So we've talked about the types of observations we can make. They can either be, norm referenced or criterion referenced. They can be tests of optimum or typical performance. Now, actually going in and, making those observations, engaging in those tests in order to collect your data. So sort of the main goal that we have, of course, in research is to determine causality, as I mentioned earlier on in some of my other videos. You're trying to determine the cause and effect relationships between variables. In order to do that, you have to determine whether the variables are correlated, establish that there's temporal precedence in the manifestation of the independent variable prior to the effects on the dependent variable, and you have to basically narrow down the field of potential variables that are potentially affecting that dependent variable, so that you can isolate a particular independent variable and assert that indeed it is this one variable that is leading to the results that we see and not anything else. Okay? And for that, generally speaking, you need to engage in an experiment. So an experiment is, like I said, really good at determining cause and effect relationships. We've got three main true experimental designs here. Now, what really sets apart the experimental design is that it has an element of randomization first and foremost associated with you. All experiments have to be randomized in the sense that individuals that are assigned to either the experimental or the control groups have to be done so in a random fashion in order to make sure that there are no biases in the selection of individuals to be part of these groups. Secondarily, there is a control group, sometimes more than one control group in the case of the Solomon design, in which you're able to examine whether or not there's a true difference between that experimental group and some group that isn't receiving any sort of treatment or any sort of stimulus in order to determine whether there's truly a change that has taken place. Okay? And then, of course, the different types of tests all have different pros and cons associated with them. So without further ado, let's take a look at some of these designs. Okay, so the first design number one, we've got the pre-test, post-test, randomized control group design. Okay, and if you look here, we've got this little symbolic model or representation of what that experiment looks like. You begin by R randomizing the group assignment. So we have R here for the experimental group, which is the top group, and R here for the control group, which is here at the bottom. And once you've randomly selected individuals to be part of the group, you can go ahead and engage in your first observation or test, which is O1 in this particular case. Then you introduce the experimental treatment, which is this X, in the experimental group, but not in the control group, so you have that basis of comparison. Then you make your secondary observation or test. And then that way you're able to see, kind of before and after, if there's a change directly based on that experimental treatment and exactly the extent of that change. But you also have the comparison of the experimental to the control group. Now, what's the potential problem here? This opens the door to one of those threats of internal and, of course, external validity, which is pre-test sensitization or the reactive effects of testing, right? If you have a pre-test, that could potentially influence the post-test, as we discussed earlier. So in that case, it might make sense to go ahead and remove the potential for pre-test sensitization. If you're concerned that your pre-test is affecting things, what you can go ahead and do is do a post-test only randomized control group design. So here we randomize the groups. Then we make our experimental group have this experimental treatment present. Control group doesn't get the experimental treatment. And then you make your only observation to see if there's a difference between the experimental and the control group. Now, you don't have that before and after the way that you would with a pre-test, post-test design, which is unfortunate, but at the same time, you're not risking the potential of pre-test sensitization here. Okay? So what happens when you want both this before and after with the pre-test, post-test, and you want to eliminate the possibility that there is pre-test sensitization? Well, that's when you go for the gold standard of experimental design, which is the Solomon 4-group design. Again, you randomly assign each of the 4 groups this time, not just 2 groups. You've got 2 experimental groups, and you've got 2 control groups. Here we've got the first experimental group with an initial pre-test observation. Here, the third one down, we have the second experimental group without an initial observation. And then the 2 control groups, one with a pretest, one without, and then the secondary observation or only observation in the case of the bottom 2 in order to determine any change on the basis of that independent variable introduction. Okay? So the reason we don't always do the Solomon 4-group design is like any other study that we have that we have potential issues with. It can be expensive, it can be time consuming, and you literally have to get twice as many individuals to participate in your study as you would with either one of these experimental designs. So I think most of the time you're probably going to want to go ahead and choose the pre-test, post-test design in order to determine causality. If you do suspect that the pre-test is going to potentially influence things, then you're going to do the post-test only. But if you have the time and the money and you want to be really comprehensive, or maybe you've already done one of these tests and you want to kind of back up your results with that gold standard once you maybe secure more funding and a bigger staff or something like that, then you're going to go ahead and do that Solomon 4-group design. Okay? Now that being said, you don't always want to do a full experiment, right? It's very time consuming, it can be very costly, especially if you're doing a pre-test and a post-test, and then the idea of having both a control group and an experimental group and really controlling all those conditions, you don't always want to jump into an experimental design before you've established that at least there's a correlation between the variables that you're exploring, and that's where kind of these pre-experimental designs come in here. Okay, so we've got the one-shot case study, the one-group pre-test post-test design, and the static group comparison design. So I think the most common thing that you're going to see sort of in an academic setting is that one-shot case study. So what I assign in all my classes is generally a one-shot case study where you're going to examine for a particular independent variable and then make observations about the group that has those particular characteristics. This can also be the way that an examination in a class takes place, right? The introduction of the experimental treatment is the class itself, right? It's the independent variable that's going to affect the dependent variable of a grade. So the class is the independent variable, taking the class is the independent variable, and then the dependent variable is your grade at the end of the class, right? So that's the idea behind the one-shot case study, is that you're going to make some sort of an observation based on whatever characteristics it is that you're looking for, okay? And you're going to see what kinds of conclusions you can come to by exploring that particular topic, okay? The one-group pre-test, post-test design is next. That's where you make it's basically looking at an experimental study without necessarily randomizing the groups that you're exploring. So what you're essentially kind of looking at there is how the before and after kind of looks before introducing some sort of an experimental condition here. So without the randomization, without a control group to kind of compare to, you got a lot of potential threats to the validity of this kind of study, right? You got history as a potential threat because you're looking at a pre-test versus a post-test. So there's something that there's got to be a time period in between those two tests, so something could happen that leads to different results. Maturation, of course, is also based on those time elements there. Instrumentation, if you change your instrument at any point between the pre-test and the post-test. Of course, you got the reactive effects of testing, as we kind of explained before, because we have a pre-test. If you select your participants on the basis of extreme scores, statistical regression is possible there. So, there's all sorts of potential problems with the one-group pre-test, post-test design. But it is useful under certain types of circumstances, right? Whereas the case study before is good for something like instruction, you're able to actually see if there's a before and after based on the introduction of a variable. So if you're like in an organizational setting or something like that, and you want to see how productivity is before introducing some sort of a new program, this might be a good thing to kind of take a look at. Okay? And then the next one, the static group comparison design. It's really good for things like pilot studies or where you're trying to find potential treatments. The idea there is that you have a static group, that is a group that probably has known each other in the past, or they're pre-established, like departments within an organization or something like that. You introduce an experimental treatment for one group, and then you do not for another group. See how they might be different. For example, you have multiple departments in a large corporation that you work for. You introduce this new mode of scoring to get people bonuses or something like that, and then you're able to compare the department that you introduced this new program to with a department that didn't have this same type of system, see what the results are between the two groups, and see if there's a fundamental difference between the two designs. Okay. Last but not least, we have quasi-experimental designs. So quasi-experimental designs are lacking one or more of the components of an experimental design, but nevertheless do try to introduce some sort of an independent or other type of experimental treatment. Well, I guess it would always be an independent variable, but an experimental treatment almost, but without necessarily having the randomized groups that you would want for those types of circumstances. And then, of course, we have a thing called the equivalent time samples design, which is really quite fascinating as well. That's a little bit different from the non-equivalent control group design, in that it looks at one group or one individual even getting multiple treatments. But we'll get to that in a second. Let's start with the non-equivalent control group design. It basically looks like a pre-test, post-test randomized control group design, except it lacks the randomization, right? So you do have that before and after of the pre-test to the post-test, and you have a control group. So, it's not ideal in terms of determining cause and effect relationships, but it's really, really effective for measuring change within a group, right? So like an organization. So as I mentioned, before, you're able to see a before and after on, implementing this new program in the finance department, and comparing that to the human resources department that didn't have the new program implemented. And you're able to see if there's actually some sort of a change going on. Now, of course, you do have, lots of threats to the validity of this particular type of study as well. So you're not necessarily able to determine cause and effect relationships, right? You have mortality potential issues because you've got a pre-test, post-test. You got selection biases, of course, because you have the two groups that have already been established. There might be, interaction between the various groups. Of course, there's history issues, all sorts of different threats that you're trying to eliminate if you're randomizing the control and the experimental group in the true experiments. But nevertheless, you can yield a lot of really good results that can be very useful for explaining the extent to which some sort of an experimental treatment can work within an organizational setting, right? Then last but not least, that equivalent time samples design. So if you'll remember the threats to validity, particularly with regard to the generalization of things, multiple treatment interference came up. Well, that's particularly because of this particular type of design. And the idea there is that you have one group or even just one individual that is going to receive some sort of an alternating treatment, where you're trying to see if a person's condition might improve, for example, by doing one set of activities or giving a drug in the case of medical research, and then stopping doing that particular treatment and doing a different type of treatment to see if there's some sort of a fundamental change over time. So you're basically maybe have two different types of drugs, like atorvastatin and andracistatin. You give the person atorvastatin for a month, you stop giving them atorvastatin, then you give them andracistatin for a month, stop giving them that, back to the atorva, back to the andraci, and then suddenly you have, you're able to see if there's a difference in the different types of treatments being done over time. Now, of course, the question is, whether or not it's actually the first drug that continues to work while the second drug is still being tested on? Is it both drugs that's resulting in the change, or what have you? And of course, it can be not drugs, but maybe some sort of a behavioral program or some sort of a policy that you're trying, and you're trying to see if there's a difference between the first type of program versus the second type of program in improving productivity at the workplace or something like that. But of course, the problem there is that you don't necessarily know which type of treatment it might be. So maybe what you want to do is establish a baseline or even multiple baselines in seeing what the variation is, and as far as the behavior is concerned, that you're exploring as your dependent variable based on the type of treatment that is being put in. So you see, if maybe you establish one baseline or two baselines where you're expecting a certain result, maybe with treatment A, and then with treatment B, the results are even better or even higher based on what you think the secondary baseline is supposed to be. So anytime you're really measuring different types of changes based on any type of introduction of a program or anything like that, you might want to consider putting together some sort of a baseline comparison so that you can see if the expectations are essentially being met by the introduction of the various types of treatments or the various types of programs. Okay? And as far as general study designs, I'm sort of done as far as that's concerned here. What we're going to be moving on is to thinking about various type of methods and things like that are going to allow you to begin to pull your data based on any of these designs that we've discussed here in the past. So we're going to be looking at, of course, survey research, primarily for quantitative research, and there are also going to be options to look at different types of qualitative research, including different types of interview style methods, and doing ethnographic sort of observations, content analysis, and things like that. So expect those to come up in the future, and hopefully to be able to put everything together now by choosing how you're going to be conducting your study, whether you're going to be doing a norm or criterion reference sort of test, if that test is going to be optimum or typical performance, and then all the considerations about how you're going to be making your observations, and the extent to which you're going to be determining cause and effect relationships as well.